In the ever-evolving world of technology, memory networks hold a position of paramount importance. Just as the human brain stores and retrieves information, these intricate systems enable machines to remember and draw upon learned data. One such fascinating system is the hetero-associative memory network. Imagine holding a puzzle piece and instantly knowing where it fits in the grand scheme of things. That, in essence, is the brilliance of hetero-associative memory networks. They are capable of recalling a complete output from a partial or distorted input, much like piecing together a puzzle from a single piece. So, what is a hetero-associative memory network? To put it simply, it is a type of memory network that associates different types of information, unlike auto-associative memory networks, which recall the same information from the input. Hetero-associative memory networks can recall associated yet different data. Imagine a scenario. You see a picture of the Eiffel Tower. An auto-associative memory network might recall the same image or a similar one. On the other hand, a hetero-associative memory network might recall a French croissant, the French language, or even the sound of a French accordion playing in the background. It makes connections between different but related pieces of information. Now let's delve into the components of a hetero-associative memory network. It comprises two critical parts, the encoder and the decoder. The encoder takes in the input data and translates it into a code. This code then gets stored in the memory network. The decoder, on the other hand, retrieves the stored code and translates it back into output data. It's like a librarian who not only stores the books but also knows exactly where to find them when needed. The beauty of a hetero-associative memory network lies in its ability to recall complete data from partial or distorted inputs. This feature is particularly beneficial in noise reduction and error correction in data transmission. It's like having a superpower that can piece together a complete story from just a fragment of information. Now, to summarize the key points discussed, hetero-associative memory networks are a type of memory network that associates different types of information. They consist of two essential parts: the encoder, which translates input data into a code and stores it in the network, and the decoder, which retrieves this code and translates it back into output data. Their unique ability to recall complete data from partial or distorted inputs makes them invaluable in fields like data transmission, where they aid in noise reduction and error correction. In essence, understanding hetero-associative memory networks is akin to grasping the concept of memory itself. It's a fascinating journey into the world of technology, where machines mirror human abilities in remarkable ways. The future of technology lies in developing these systems further, making them more efficient, and integrating them into our daily lives. In the grand puzzle of technological advancement, hetero-associative memory networks are a crucial piece.